Okay, now we're going to look at practice C, which is the work kinetic energy theorem, and we're going to look at problem number 1. A student wearing frictionless inline skates on a horizontal surface is pushed by a friend with a constant force. So we're going to write our given. So F is equal to 45 newtons. How far must the student be pushed starting from rest? So the initial velocity is equal to 0, so that her final kinetic energy is 352. So her initial kinetic energy is going to be 0 because if her velocity is 0, remember that kinetic energy is 1/2 mv squared. So if her velocity is 0, her kinetic energy is 0. So then it says her final kinetic energy is 352. And we want to find how far she goes. Now, in your book, these practice problems are all grouped together using the same equation. So this is the one for doing the work kinetic energy theorem. But as you practice, then when we get to other problems in the back of the chapter, then you have to determine how am I going to solve this problem. Now, when you're not sure what to do, you go to the end. We want to find how far it went. Now, we learned yesterday that work is equal to FD. That's what we learned yesterday. So we can find how far by finding D. But what we learned today is, we learned today that work is equal to the change in kinetic energy. And this is how we're going to work all the problems in practice C. So what do I know? I know work is equal to FD, and I know the change in kinetic energy is equal to KEF minus KEI. Now what I can do is I can expand this out a little bit more and say FD is equal to KEF would be mVF squared, 1/2, because kinetic energy is 1/2 mv squared, minus 1/2 mvi squared. Now we know that this is 0, so I have FD is equal to 1/2 mVF squared. I'm given the force. I don't know how far it went. That's what I want to find. I don't even have to do all this because they gave me KEF. Oh, so this problem's easy. Whoops. So FD is equal to KEF. So all I want to do is solve for D. So I'll rearrange the equation and say D is equal to KEF over F. Now if they didn't give me the kinetic energy and they gave me the mass and the velocity, then I could rearrange this to solve for D. So it depends on what is given. This is the first problem, so they made it easier. So it's 352 joules divided by 45 newtons. So on my calculator, 352 divided by 45 comes out to be 7.8. I know displacement's in meters, but I don't know if I made an algebra mistake, and I want to check it. So how am I going to do that? I'm going to check my work by looking at my units. Remember, in physics, you have a foolproof way to check your work every time you do a problem by carrying your units and canceling them. So in the numerator, I have a joule. Well, I know a joule is a newton times a meter, divided by a newton. So the newton in the numerator cancels with the newton in the denominator, and I end up with meters. Is that the correct unit for displacement? Yes. So I see I didn't make an algebra mistake. And that's it.